3 days ago, something on Voyager 1 made NASA's Deep Space Network pause. A signal came home that the engineers did not expect. Not the kind of signal they were trained to handle in nearly 50 years of flying this little machine. Within minutes, the flight director called an emergency stand-down. Scientists are stunned. Nobody saw this coming. What you're about to hear has been kept quiet for days, and what Voyager 1 sent back from the edge of the stars changes everything we thought we knew about the place we live in. Stay until the end. The final part of this story is the part nobody is talking about. Let me take you back to the beginning, because to understand what just happened, you have to understand what this little spacecraft is and where it is right now. Voyager 1 left Earth in 1977 from a launch pad in Florida. It was the size of a small car. It weighed less than a piano. And it was given a simple job to fly past Jupiter and Saturn and send back pictures of worlds no human had ever seen close up. That was it. A flyby mission. A 4-year road trip. Nobody at the time thought it would still be flying almost 50 years later. Nobody thought it would still be talking to us from farther out than anything we have ever built. But here's the thing about Voyager 1. The thing that almost nobody realizes: it never stopped. Every single day since 1977, it has been moving away from Earth at roughly 38,000 miles an hour. It has never slowed down. It has never turned around. It has never stopped listening for our radio commands. And right now, in July of 2026, Voyager 1 sits at roughly 172 astronomical units from the Sun. That is 25.8 billion kilometers. That is 16 billion miles. That sounds insane, but it is not even the most insane part. The most insane part is what comes next. In just a few months, on about November 13th this year, Voyager 1 will pass a milestone humanity has never crossed. A radio signal traveling at the speed of light will take a full 24 hours just to reach it. One light day. It will be the first object ever made by human hands to be one full day of light away from home. Just let that sit in your mind for a second. Light, the fastest thing in the universe, the thing that races around the Earth 7 times in a single second, will take an entire day to crawl across the gap between us and this little spaceship that we built before most of you watching were even born. Voyager 1 is now so far away that when an engineer at the Jet Propulsion Laboratory in California presses a button telling it what to do, the signal does not arrive until tomorrow. And Voyager 1's reply does not come back until the day after that. We are flying a probe at the edge of tomorrow. And it is not just a probe. It is a messenger. We bolted a gold-plated copper record to the side of this thing, a 12-inch disc we called the Voyager Golden Record, and on it we put greetings in 59 human languages. We put sounds of rain, of wind, of thunder, of a crying baby, of someone kissing their mother goodbye. We put 90 minutes of music from Bach to Chuck Berry to a Navajo chant recorded under a desert sky. We put 115 pictures explaining us, our DNA, our bodies, our cities, our planet. We put instructions written in symbolic code teaching any listener how to play the record. We did all of that before Voyager even finished flying past Jupiter. We did it because Carl Sagan and a small committee of scientists and artists understood something most people do not. The chance that anyone will ever find this little disk is basically zero. The galaxy is too big. The disk is too small. The timescales are too long. And we sent it anyway. That is the kind of stubborn, hopeful creature we are. The same mission that took the pale blue dot photograph in 1990. That tiny smudge of light on a streak of sunbeam showing Earth as a single pixel suspended in a sunbeam. The same mission is the one now sitting out there at 1 light day's distance, telling us about the shape of the galaxy. Carl Sagan wrote an entire book about how that one image, that one pixel showing our home planet as essentially nothing, should change how we treat each other. Voyager 1 has been teaching us that lesson, on and off, for almost half a century. And now, in 2026, it is teaching us another one. Now let me tell you about the team that still flies it, because this is the part the public never sees. There is no big shiny control room for Voyager anymore. The mission has been folded into the lean, long tail of planetary exploration at JPL. The people who command it now were not born when it launched. They grew up reading about it in school. They joined the lab, wanting to work on Mars rovers or Europa missions or whatever the cool new thing was. And then somewhere along the way, they inherited Voyager. They inherited a little spacecraft that was older than they were, that ran on a plutonium power source called an RTG, a radioisotope thermoelectric generator, that decays a little every year, that gives less and less wattage every year, that has forced the team to turn off instrument after instrument just to keep the rest of the probe alive, long enough to say what it has come all this way to say. In 2025, NASA shut off Voyager 2's low-energy charged particle instrument to save power. They shut off Voyager 2's cosmic ray subsystem that same year, and in April of 2026, the team shut off the cosmic ray subsystem on Voyager 1 too. with tests planned for May and June and a possible repeat of the same shutdown on the spacecraft's other twin systems under evaluation no sooner than July if those tests went well. That is the kind of calculus the engineers do every season. Which instrument gets to keep listening? Which instrument gets to finally rest? Which bit of science gets sacrificed so the rest of the probe can whisper for one more year? There is no dramatic moment when an instrument shuts off. It is a command sent through the deep space network, a tiny carrier tone, a binary yes, and the instrument goes quiet forever. And that quiet is felt in the building, because every one of those instruments is somebody's life work, somebody who spent decades building hardware that flew past planets and is now being politely turned off, so the rest of the spacecraft can keep working. And that is exactly why what happened 3 days ago matters so much. Because a spacecraft that far away and that fragile is supposed to be almost silent by now. The instruments are old, the power is fading. NASA has been shutting things down for years to keep it alive. So when a signal came in from Voyager 1 3 days ago that nobody was expecting, you can imagine the room at JPL going quiet. Let me set the scene properly. In November of 2023, Voyager 1 started doing something that scared everyone. It lost the ability to send back normal science data. The spacecraft was still talking to NASA. The little radio tone was still there, the carrier signal, the beep that says, "I'm alive," and pointed at Earth. But the actual numbers, the actual measurements of magnetic fields and plasma and cosmic rays, the data the mission was built to send home, all of it turned into gibberish. Engineers called it a glitch. They called it officially a telemetry readout problem tied to the flight data system, the FDS, the computer on board that organizes and packages the science before sending it down. The FDS itself was still functioning. But one of its critical memory locations, stored on a tiny chip from 1977, was no longer accessible in the normal way. So Voyager 1 sat out there in interstellar space, healthy enough to broadcast, healthy enough to listen, but unable to say anything that made sense. Months went by. Engineers tried sending commands. They tried resets. They tried clever workarounds. They tried patching around the broken chip entirely. And the whole time, the spacecraft kept drifting 1 more million miles away every few days, farther than we have ever reached, with a broken voice. There was a real chance back then that Voyager 1 would end up like so many other old spacecraft, alive but mute, drifting until its plutonium ran out and the little transmitter finally went cold for good. But then, in the spring of 2024, something happened that made even the skeptics on the team sit up. The engineers at JPL figured out how to rewrite the code so that the working parts of the computer could read memory in chunks instead of all at once. They taught an old dog new tricks. They essentially found a way to ask the same question in pieces, so the broken chip could still give an answer, slowly, one little piece after another, and the data started coming back, slowly at first, then faster, then fully. The voice was mended, the little spacecraft could talk again, and inside that data, in the weeks and months that followed, was something the team had been waiting almost a decade to see properly. Long before the glitch, long before the broken chip, Voyager 1 had crossed a line in 2012 that nobody had ever crossed before. The heliopause, the edge of the sun's magnetic bubble, the place where the solar wind gives up and the pressure of interstellar gas takes over. First human object to leave the sun's bubble of influence, first to feel the wind of the space between stars. That was already the headline of the decade, and it made front pages and magazine covers and Carl Sagan-style reflections all over again. But there was something even stranger hidden in the data from that crossing, something nobody fully understood until the voice came back online. The plasma wave instrument, the PWS on Voyager 1, had been picking up a faint hum, a constant, very weak, narrowband emission, almost like background ringing, that showed up in the readings starting around 2017 and never stopped. Scientists at Cornell University led the detailed analysis. They published it in the journal Nature Astronomy in 2021, and what it was the sound of interstellar gas vibrating. The space between the stars is not empty, not really. It is filled with a thin plasma, a kind of charged static, the leftovers of ancient supernova explosions, hydrogen atoms stripped of their electrons, drifting in the dark at temperatures of tens of thousands of degrees. And Voyager 1, floating way out there in that dark, was hearing that hum with a 49-year-old radio antenna. That on its own was a discovery that changed textbooks. It told us the interstellar medium had structure. It told us our local patch of galaxy was not silent but singing. But what came after, when the full data set came back online in 2024, is what changed everything. The electron density around Voyager 1, the sheer amount of charged material in the space it was passing through, started rising in 2013. Not a little, steadily. By the middle of 2015, it had reached something like 40 times the levels it had when it first crossed the heliopause. 40 times. That is not a little drift. That is the spacecraft flying through something much denser than anyone realized. Imagine driving your car through fog. You expect occasional thicker patches. You do not expect the fog to suddenly become 40 times thicker than the last mile with no warning, no obvious reason. That is what Voyager 1 was telling us. The space between stars is not uniform. It has walls, it has pockets. It has rivers and eddies. It has a shape nobody mapped. And the hum, that constant vibration the plasma instrument has been hearing for nearly 10 years, is the sound of our little spacecraft sailing through a region of the galaxy we did not even know existed. Now, to be fair, this was not the first hint. Back in 2019, a team published a paper saying Voyager 2's crossing of the heliopause had shown a similar plasma density jump, a marked increase in the density of the material out there. The interstellar medium has structure, they said. There are clouds inside clouds. There are pockets of denser gas riding along inside the more diffuse, hot wind. Their paper helped confirm that the local interstellar medium is lumpy, slow-moving, and unpredictable. But that was already 5 years ago. And the assumption ever since has been that there are ways to fold those observations into the standard model of our local galactic neighborhood. Just adjust the density here, adjust the temperature there, add one more cloud to the map, it would all still fit. That is what most of the textbooks still say. But here is where things take a strange turn. And I want you to feel the weight of this next part, because it is the part of the story that nobody is talking about, the part that changes everything we thought we knew. 3 days ago, when the new data packet came down from Voyager 1, the engineers noticed that the hum had shifted, not louder, not quieter, shifted in pitch. The frequency of the plasma waves had changed in a way that did not match any model currently in the literature. The interstellar medium out there should behave a certain way based on what we know about how nearby supernovae blew bubbles in the gas millions of years ago. We know we live inside something called the local bubble, a cavity carved out by a string of supernova explosions over the last 10 or 15 million years. We know our sun is sitting inside that bubble right now, along with a few nearby stars. We know the sun and the heliosphere are also drifting through something called the local interstellar cloud, sometimes called the local fluff, a denser knot of cooler gas embedded inside the larger hot bubble. We know from radio and ultraviolet measurements that there is a wall of denser, colder hydrogen out at the edge of the local bubble, the place where the bubble's hot interior meets the cooler surrounding galactic gas. But we have never been there. We have never taken a direct in situ measurement of that wall. We have only inferred its existence from spectra. And the new reading from Voyager 1 suggested that the wall is closer than anyone thought. The plasma is denser in the direction Voyager is flying than the models predict. The temperature signature is colder than the models predict. And the long suspected wall of denser hydrogen at the edge of this bubble, the so-called boundary where the local interstellar cloud meets whatever is outside it, appears to be closer than the simulations were giving credit for. Voyager 1 may be approaching something, not a star, not a planet, a wall, a real physical wall of cold hydrogen gas sitting out there in the dark that our sun is drifting toward right now along with every planet, including Earth. Think about that for 1 second. You're sitting in your room right now watching this. Outside your window is the street, the town, the country. Above all of that is the atmosphere. Above that is space. Above that is the solar wind. Above that is the heliosphere, the protective bubble the sun blows around us. And above that, at long last, is the hot, thin gas between the stars, the stuff Voyager 1 is swimming through. And the sun is also inside a small, denser cloud within that larger hot bubble, the local cloud, where the temperature is lower and the gas is denser. And beyond that, somewhere out there, in the direction Voyager is flying, is a wall made of cold hydrogen that we have known about in theory for years, but that nobody has ever actually touched. Voyager 1 might be about to touch it. Within the next few years of its journey, it may cross a boundary we did not even know how to draw. Not a black hole, not a planet, not a star. A wall of cold gas the size of a chunk of the galaxy, sitting quietly in the dark, waiting for our little spacecraft to bump into it. And that is why the team at NASA has been so quiet for the last 3 days. Because if that reading is right, if the shift in the plasma hum really means Voyager 1 is sensing a wall we never modeled, then the map of our galactic neighborhood, the map every textbook has had for almost 30 years, is wrong. Wrong in a way that matters not just to astrophysicists, but to anyone who has ever looked up at the night sky and wondered where we are. We are not drifting through an empty, calm sea. We are drifting toward a shoreline. And Voyager 1, the little machine we built before the personal computer existed, is the first ship to feel the wind shift. Now here's the part that gives me chills. If Voyager 1 is sensing a wall of denser cold hydrogen, then Voyager 2, which is flying out in a different direction, in a different part of the sky, has likely already crossed through a similar structure on its way out. That might explain some of the strange readings Voyager 2 sent back over the years, including the puzzling plasma jumps observed at its own heliopause crossing in 2018. That might also explain why cosmic ray measurements from the two spacecraft do not perfectly match. Voyager 1 has been seeing a steady rise in higher energy cosmic rays from outside the heliosphere. Voyager 2 saw the same at first, but the long-term pattern of how those cosmic rays vary, the way they pulse and fade in response to solar activity, has been subtly different on the two spacecraft. Some scientists have wondered whether that difference is purely about the two probes being in different parts of the sky, one above the plane of the solar system and one below. Other scientists have wondered whether the difference is because one spacecraft is approaching the wall and the other is leaving it behind. If you fly a boat into a harbor, your wake looks different than the wake of a boat leaving the harbor. Maybe the two Voyagers are doing something similar, except the harbor is made of cold interstellar hydrogen and the boats are 49-year-old robots the size of cars. The reaction inside the small community that still works on the Voyager mission has been exactly what you would expect. Some scientists are cautious. They point out that one shift in one frequency on one old instrument on one aging spacecraft is not enough to overturn a model that has held up for 30 years. They want more data. They want to see if the trend holds over weeks and months. They want to rule out instrument drift, the slow decay of sensors that have been running on plutonium power for almost 50 years in deep cold. They want to run the numbers in 3 different ways before they will say the word wall out loud in front of a camera. That is the responsible scientific reaction. And it is exactly what you would hear from anyone who spent their career not jumping to conclusions. But there is a different conversation happening in hallways and on private message boards. Younger scientists, postdocs, the people who were in middle school when Voyager was launched and who grew up inspired by its lonely journey, are saying something different. They are saying, look at the pattern. Look at the year after year rise in electron density. Look at the constant hum that should not exist this far out if the local interstellar cloud were as thin as the old model said. Look at the temperature skew. Look at the fact that the best fit to the new reading is not the calm, warm cloud we have always assumed, but a colder, denser, compressed region, the kind of thing that forms on the inner edge of an approaching wall. They are saying that maybe, just maybe, our entire picture of the local interstellar medium was a rough guess that worked well enough to plan missions, but was never actually tested. And now finally, after almost 50 years, it is being tested by something real, by Voyager, by a machine we built before most of us were born. There has been quiet disagreement inside the team about how much to say publicly. Some members argued that this should not be released until a peer-reviewed paper could be written. Some argued the public, the people who paid for this mission, through taxes over generations, deserve to hear the first hint of what Voyager is whispering. The decision was made to do what you might call a soft release. A small note in a NASA blog, a cautious reply to a few press inquiries, and that is how we got to where we are now. The breadcrumbs are out, but they have not been framed yet. The story has not been told yet. And that is where this channel comes in, because the story matters, not just to people who love space, but to anyone who has ever wondered what kind of house we live in. And I want to pause here for a moment and speak directly to you, because this part is not really about the science. Imagine for a moment that you are sitting in the Voyager mission support area at JPL. It is late at night. The lights are dim. The screens are green. A young engineer has been on shift for 9 hours waiting for a signal that takes by itself 22.5 hours one way to crawl home from interstellar space. The signal finally comes down. The first numbers appear, and they do not match. They really do not match. You can feel the room change. You can hear the small cough of someone who has been staring at a screen too long. You can hear the chair roll back. You can see the scientist pick up the phone and dial the principal investigator at home, the way they do when something is real. And that is what happened 3 days ago. Not because Voyager 1 sent back a movie or a photograph, but because it sent back a frequency, a tiny shift in pitch. The sound of our little ambassador brushing up against something we told ourselves was far away but might actually be close. Now zoom out with me. Forget the data and the frequencies and the plasma. Forget Voyager 1 for a second and think about what it means that we built a thing, sent it out into the dark before most living adults were born, and now it is still serving us. Still sending postcards? Still alive? Still telling us things we did not know about the place we live? In a few months, on about November 13th this year, Voyager 1 will be a full light day away. A signal from it will take 24 hours to reach us, and we will fire back a response, which will take another 24 hours to arrive. That round trip, 2 days, will be the smallest unit of conversation we have with something we built. We will be talking across a 2-day delay to an object that has been traveling for nearly half a century. And in those 2 days, while the signal crawls across the solar system and out beyond it, Voyager 1 will keep moving, keep listening, keep feeling the hum of the space between stars. And if the new reading is right, in a few more years, it will brush up against the wall we never modeled, the edge of the cocoon around us, the shoreline of the sea we have been sailing through without knowing where the shore was. And when it does, it will tell us. slowly, in weakest whispers, in tones lost in noise, in data packets that look like static to anyone not paying attention. It will tell us that our map was wrong, that we live in a more interesting neighborhood than we knew, that the galaxy has texture, that there is a frontier closer than we thought. And that is the bigger question, the one this whole mission has always been about. Are we alone? Not in the cheesy way, not in the little green men way, in the deep way. Are we alone in the sense that nobody else has done what we have done, built a thing, sent it out into the dark, written a message on a golden record and bolted it to the side, asked in a way that crosses light years and decades, can anyone hear us? Voyager 1 is the first time in the history of our species that we sent our voice into the long night on purpose. And now, almost 50 years later, it is still talking. And what it is telling us now is that the place we live in is stranger, more layered, more interesting, and in some quiet ways more fragile than the textbook suggested. There's a wall out there, a wall made of cold hydrogen, and we are drifting toward it. So is the sun, so is Earth, so is everything you love. Slowly, over millions of years. But still, we are moving. And we did not know we were moving with a destination until Voyager told us. That realization is bigger than one science paper. It says something about what humans are capable of doing when we decide to be patient. When we decide to listen to one little machine for 49 years and never turn it off. When we decide to read the hum in its data instead of dismissing it as noise. When we decide to build a thing and not give up on it, even when everyone else has moved on to newer toys. That is the kind of stubborn, quiet curiosity that finds walls at the edge of the galaxy. It also says something humbling about us. Because we have been telling ourselves what the local interstellar medium looks like for decades from the comfort of Earth's atmosphere, using telescopes to look out at the nearest stars and trying to infer what must be in between. We have been drawing maps of the local bubble and the local cloud without ever once sending a probe out to touch what we were drawing. And we were wrong, or at least we were less right than we thought. The universe is reminding us, the way it always does, that the map is not the territory. Every time we leave the building and really go out there, real data flows in and the map has to be redrawn. Voyager 1 is doing that for us right now, slowly, patiently, from 1 billion miles past where it was ever designed to go. And there is one more thing worth saying before we close this out. We should not pretend this is a small update. It is not. It is also not the end of the mission. It is the middle of it. We are in the moment when Voyager has finally crossed the edge of the system that made it, and it is now telling us what the deeper neighborhood sounds like. Every reading from here on out is a first. Nobody has ever measured plasma at 1 light day's distance from Earth in the direction Voyager is flying. Nobody has ever felt the magnetic field of a wall that we could not prove existed from the ground. Nobody has ever sent a command through the deep space network knowing it would only touch its target a full day later. We are in new territory, and the only way to learn about it is to keep listening to the little machine we built before most of today's scientists were even alive. That is what makes Voyager 1 feel like a family member. Not because it is human, not because it feels anything, but because we have been responsible for it for almost 50 years. We fed it power from a dying lump of plutonium. We shielded it from the cold. We kept its antenna pointed within a fraction of a degree of Earth. We wrote its software. We hugged it through solar storms. We took pictures with it and cried about what we saw. And we did not abandon it when it got old. We are still flying it. We are still turning off instruments we love so the rest of it can keep whispering. We are still on shift at midnight, half awake, waiting for the faintest carrier tone from a place so far away the signal takes almost a whole day just to get here. That is commitment. That is love in the only language an engineer speaks. Let me close this out the way it deserves to be closed. Voyager 1 is still out there. Right now, at this very moment, drifting through the dark at 38,000 miles an hour, it is feeling the hum of interstellar plasma. It is taking in the magnetometer readings. It is sliding closer to a boundary that it will be the first thing in human history to touch. Its plutonium is fading. Its instruments are going dark one by one, gently, carefully, the way an old engineer turns off machines at the end of a long shift. But it is not done. It still has years left. And the team at JPL is still awake for it, still answering its signals, still squeezing out every last drop of science from something we built in the era of rotary phones. If you made it to the end of this video, you already know something important. You know that the picture on the wall is wrong. You know that what we have been told about the local interstellar medium needs updating. You know that the hum Voyager 1 has been hearing for nearly a decade may not just be the boring heartbeat of empty space. It may be the sound of our spacecraft picking up the outline of something enormous and close, something we have never mapped, something that we and every star around us are drifting toward through the slow, patient clock of the galaxy. And you know that one tiny machine, older than most of the people watching this, is the reason we are standing here realizing it. That is what I want you to sit with tonight when the sky is dark and you step outside. Somewhere out there, way out there, past every planet, past the moon, past the planet you learned about in school, past every star and any constellation you can name. Our little ambassador is still moving, still humming, still listening, and it just told us something we did not know. The wall is closer than we thought, the map is wrong, and the story is not over. Hit subscribe if you want to follow this as it unfolds, because this is the kind of mission that does not announce big, flashy press conferences anymore. It does not have a TikTok team. It has a small group of tired engineers and scientists holding onto one little machine for as long as it will let them. And every now and then, when they find something like this, when the data whispers something new, they let us listen in, I will keep covering every update the moment it drops. Drop a comment below and tell me, does this change how you feel about where we live? Are we in a calm, open sea, or are we drifting toward a shoreline? Tell me what you would put on a second golden record if we could send one out today. I want to know what you think, because this is exactly the kind of question nobody should answer alone.